So let's continue with this series on biases and how they affect our decision making. So I'll just go over shortly, briefly, over those other biases that we've had and we talked about, and we said the need to be right is another bias that affects a lot of people. The need to be right is a bias that affects a lot of people, and we said that we've been brought up in this society and we have had this belief inculcated in us that the student that makes 90% is better than the student who has 20%. The vaccine that is 90% is better than the vaccine that is 20%. The investment that is 90% right is better than the investment that is 20% right. And we said that this is not always the case. It is very possible to be right most of the time and end up losing money in this case. Therefore, what you should be more concerned about is the expectancy of your decision and options. So let us see what I mean by expectancy. So we take two examples. One has 90% accuracy and the risk reward is 1:0.1. In other words, I risk 1 shilling, I get 0.1 shilling. Then the other one is 20% right, and the risk reward is 1:20. I risk 1 shilling, I get 20. So assuming I'm starting with 1 million shillings over here, so this would be what would be the ending balance. So here I am I am right, so I made 100,000. I am wrong over here, so I lost what I risked. Here I made 100,000. Here I made 100. Here I made 100. Here I made 100. Here I made 100. 1, 2, 3, 4, 5, 6. Then let's go to the other one. 100. Another one. 100. Then I lost on the last one. I lost 100,000. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Then I made 100 on the 10th one. So let's see the probability I've lost one. Yes, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So my ending balance is 900 minus 100. That's 800k on this end. So I take the same 100. I lose 100 over here. Just give me a minute. Let me just I lose 100, then I lose another 100, I lose another 100, then 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 I lose another 100k. So in total I've lost 900k. But on the 10th time I win, and we said the risk to reward in this case is I risk 1 shilling. If I'm right, I get 20. If I'm wrong, I lose what I risked. So in this case I made 100k times 20, which gives me 20m over here. 20m, yes, that's correct. That's 20m. No, let me see. 20 it's 2m. Yes, correct. I noted that was an error. So I made 2m over here. So 2m I'll deduct from my 900, which I lost initially, and my ending balance is 1.1 m. Now the reality is that I was actually wrong on most occasions, but because my risk reward was high, the ending balance was higher than the person who was right most of the times. But if I was to give these two investment products to people and I tell them this is investment product A, this is investment product B, choose one. Most people would pick investment product A because they are right most of the time. But being right does not mean you're making money. Now, the reason why they would do this is because we are subconsciously wired to prefer A over B. Now, therefore, in summary, what we can say about this is that what is important is not the probability of you being right. What is important is the expectancy, and the expectancy is how much do I make for each risk that I take. So for example, expectancy here will be the probability of winning times the average win minus the probability of losing times the average loss. This is basically how you calculate expectancy, and you will find most of the times that what really matters in this equation is basically these two over here, not so much as this. And that is how you make the right decision in this context. But now that notwithstanding, we can be able to see it is possible to be wrong more times and still make money, and be right most times and lose money. And we said businesses today are structured in this way. The business that would probably epitomize A would be one of Dukas. A person buys bread, makes 0.1 on it, or 10% on it, basically 10% gain on it. Now takes another product, makes point something, takes another product, makes point something. Now the probability of them being right is very high because they have the traffic, and the traffic has the need for that product. But when we look at the margins that they're making, the margins are so small. The margins are very, very small. Now, if you take the person selling the car, they buy it for 1M, sell it for 1.1. Now, again, the margins are so small compared to the risk that this person is undertaking. And we said last time, if it wasn't for insurance, the person that is in this context over here, and this is a car, and they only lost that car once, they need to sell at least 10 cars before they break even. That is how bad that is. And we said a business that epitomizes investment product B would be one of selling properties, where you buy a large piece of land, then you subdivide it by 100 times, then this 100 times you sell each for 1M. The gains that you will make from this will be anything between 1:2 all the way to 1:20, depending on the situation on the ground. Therefore, this is a high expectancy investment. This is a low expectancy investment. Therefore, the most preferred and the proper investment will be the one with high expectancy, even though you are not right always. You cannot get it right always. There are chances that you will pick a property and it doesn't pick at all. Yet you can have 10 properties and about 5 or 6 did not perform the way you expected, but the 4 that performed the way you expected cover for the other 6 that did not make it. That is the basic summary of this whole thing about need to be right. So let's just wrap that up and go on to the next one.